quantum portal hidden in every black hole. For decades, we've been told that black holes are cosmic dead ends, a one-way ticket to oblivion. They're the universe's ultimate monsters, objects so dense their gravity warps the very fabric of reality into a prison from which nothing, not even light, can escape. But what if that isn't the whole story? What if, hidden inside the most destructive force in the universe, lies its greatest secret, a gateway to another realm? Some of the most mind-bending theories in physics are now suggesting that at the quantum level, black holes might not be destroyers at all. They might be something else entirely, portals connecting us to a much larger cosmos. The question is, are we ready to see what's on the other side? Section 1. The cosmic monsters we thought we knew. To understand this incredible possibility, we first have to understand the monster itself. As predicted by Albert Einstein's game-changing theory of general relativity, a black hole is what's left when a massive star dies and collapses under its own weight. Think of the universe as a flat sheet. If you place a bowling ball on it, the sheet warps. A black hole is like dropping an object with almost infinite mass onto that sheet, punching a hole so deep it becomes a bottomless pit. This cosmic pit is surrounded by a boundary called the event horizon. It's not a physical surface, but a threshold of no return. Anything that crosses it, a star, a planet, even a photon of light, is inevitably dragged toward the center. And at that center lies one of the most terrifying ideas in all of physics, the singularity. According to classical physics, the singularity is a point of zero volume and infinite density, where everything that ever fell in gets crushed into nothing. At this point, the laws of physics as we know them completely break down. For a century, this was the accepted story. A black hole was a final stop, a place where matter, energy, and information go to be erased from the universe forever. It's a neat but deeply unsettling picture. But there's a problem. A ghost in the machine that refuses to let information die. And that ghost is quantum mechanics. Section 2. The quantum ghost in the machine. See, our universe is run by two great sets of rules. General relativity, which governs the very large, planets, stars, and galaxies. And quantum mechanics, which governs the very small, atoms and particles. For the most part, they work perfectly in their own domains. But they clash violently right at the edge of a black hole. One of the most sacred laws of quantum mechanics is that information can't be destroyed. Every bit of information that makes up an object, its mass, its spin, its essence, has to be conserved. You can burn a book, but if you could gather every particle of ash, smoke, and heat, you could theoretically reconstruct the original pages. Information changes form, but it never, ever vanishes. Yet, a black hole seems to do exactly that. It swallows information and crushes it at the singularity. This epic disagreement is known as the black hole information paradox, and it's been one of the biggest headaches in physics for 50 years. The great Stephen Hawking made things even weirder when he discovered that black holes aren't completely black. He proved that thanks to quantum effects, they slowly leak radiation over trillions of years, a process now called Hawking radiation. This leak causes the black hole to eventually evaporate and disappear. But his math showed this radiation was random, containing no trace of what fell in. This made the paradox even worse. If the black hole vanishes, where does the information go? Does it just wink out of existence? For decades, it seemed one of the pillars of physics had to be wrong. But what if they were both right? Recent breakthroughs, involving complex ideas like quantum extremal surfaces, now suggest the information might escape after all, perfectly preserved, but hidden within the Hawking radiation in an incredibly scrambled form. This might solve the paradox, but wrestling with it has forced physicists to consider an even stranger possibility. What if the inside of a black hole isn't a dead end, but a new beginning? Section 3. The bridge at the end of spacetime. The solution might lie in reimagining what the singularity really is. What if it isn't an infinitely dense point, but a doorway? This is where the idea of a wormhole, or what scientists call an Einstein-Rosen bridge, comes in. It's a theoretical tunnel through spacetime, permitted by Einstein's own equations, that could connect two distant points like a cosmic shortcut. The problem has always been that these bridges are ridiculously unstable. General relativity predicts they'd collapse the instant they formed. To hold one open, you'd need a bizarre ingredient called exotic matter with negative energy, something we've never observed just floating around in space. But this is where quantum mechanics might come back to save the day. Some physicists now believe that as you approach the heart of a black hole, the still mysterious laws of quantum gravity could take over, preventing a total collapse into a singularity. Instead of a point of destruction, this intense quantum pressure might forge a structure that acts less like a pit and more like a passage. While there's no consensus that this could create a stable, human-sized wormhole, it's a tantalizing theoretical possibility. This idea is supercharged by a radical hypothesis from 2013 known as ER equals EPR. Proposed by physicists Leonard Susskind and Juan Maldacena, it suggests a deep link between wormholes ER and quantum entanglement EPR. The theory posits that any two entangled particles are secretly connected by a microscopic wormhole. If this is true, then the inside of a black hole, a place of immense entanglement, might not be a point of destruction, but a vast network of these space-time tunnels. Section 4. Knocking on the door of the multiverse. If a black hole could be a stable wormhole, it begs the ultimate question: where does it lead? The simplest, and maybe safest answer, is that it connects to another point in our own universe. But a far more profound, and I have to stress, highly speculative idea is that it could be a gateway to another universe entirely. This opens up the mind-bending concept of the multiverse. Each black hole in our universe might be a seed for a new baby universe. Our own Big Bang might not have been a beginning from nothing, but a big bounce, the result of matter gushing out of a white hole, the other end of a wormhole connected to a black hole in some parent universe. Now, let's be clear. These ideas are on the absolute frontier of theoretical physics. We have no direct evidence that black holes are portals. In fact, NASA's official position is that a black hole is not a wormhole to another dimension or universe. Still, physicists are trying to figure out if we could ever even spot one. Some theoretical studies suggest a wormhole might bend light in a slightly different way than a standard black hole, creating a unique signature we could look for with our telescopes. The universe is far stranger than we can imagine, and we are only just beginning to pull back the curtain. If these ideas challenge your perception of reality, make sure to subscribe and ring the bell so you don't miss our next journey into the deepest mysteries of the cosmos. And let us know in the comments, if you could step through a black hole portal, what do you think you would find on the other side? We started with black holes as the universe's destroyers. We end with them as potential creators. The fierce battle between Einstein's relativity and the weird rules of quantum mechanics may not be a conflict after all, but a signpost pointing toward a deeper truth. The information paradox that haunted physics for half a century might be solved if information doesn't die, but simply takes a path we never imagined. Black holes may not just be objects in our universe. They might be part of its fundamental architecture. They might be bridges, gateways, or even, as another wild hypothesis suggests, the universe's most powerful quantum computers. What is clear is that the story of the black hole is not over. Its greatest secrets are still waiting for us, hidden just beyond the event horizon, in the quantum heart of the abyss.